Hello friends, myself Vikas Shakya, and in this series of algorithms I'm just going to discuss about the data structures, the array, and since array is a very simple data structure, it's nothing there to worry much about, like how the elements are assessed and how they are arranged in the memory. So I don't expect that you would like to expect that I should explain the arrays as well, the basics of arrays. If you want, you can comment on the video in the YouTube channel, in my YouTube video, and then I can explain it if you need, but I don't think there is anything specific needed to tell you about the arrays. Arrays are very simple data structures. Okay, so let's quickly take one problem from the arrays, and this problem is like you have given an array of elements where there are a number of elements like 17, 6 and up to there are 10 elements, and you have to find out the third element, which is the largest, which is the smallest element, third smallest element. Like here, if you say like I have three elements, 3, 2, 1, then what is the third smallest element? 3 is the third smallest element. What is the first smallest element? 1 is the first smallest element, right? So same thing we want to do with this array. Okay, so if you want to do the same thing with this array, then in that case you can easily find out that which element is the third smallest element in this array. You can see that there is 6, there is 8, there is 9, there is 7. So the smallest one is 6, right? Then the second smallest one is 7, and then the third smallest one is 8. So this should be our answer. The 8 should be our answer. But how to find that? How to reach that 8? What kind of approach we can take, right? So I would suggest you guys to just stop this video and then try it yourself before you move into this video to see what kind of solution I'm going to provide. Maybe there could be other solutions which are better than my solution, but I'm just going to explain what I found it and what I did. Okay, so just stop the video and then come back. Okay, so I hope you might have tried it yourself. Okay, so let's see how we can achieve that. See, in my college days, when I got this problem, when someone asked me this problem, like you have to find the second largest element, you have to find out the second smallest element, or you have to find out the third smallest element. Then what I did, like I had at that time I studied about the selection sort. I have worked on the selection sort. So what I did in selection sort, if you remember that there are a few things like this thing is simple array, right? So I will apply selection sort in this. And I will not do the selection sort for entire array. I will only sort this array I will only iterate this array during the selection sort iteration. When you apply the logic of selection sort, I will apply this logic only 3 times. I will run my loop 3 times. Okay. If I have to find out the fourth largest element, then I will run this loop 4 times. If I have to find out the second smallest element, then what I will do, I will execute my loop. I will run my loop for the 2 times. Okay, so that way I used to do. So let's see what is that, what I used to do. So first of all, in selection sort, you might be aware, like you pick this element, you keep this element, and then you keep comparing these elements. Like you will compare the first element with the 0th element. If the 0th element is smaller than the first element, this element, if this is smaller than this, then you swap. Like this one is smaller, so I will swap it. So 6 will be here, and then I will go to 8, right? And then if I found like 8 is smaller than this, which is not, right? So what I will do, I will keep 8 there, and then what I will do, I will go to 20. 20 is also not smaller than this one. The 6, now 6 is at the 0th position, right? So 20 is not smaller than 6, so 20 will also be there. Similarly 9, similarly 11, nothing is going to be swapped down. Similarly 22, similarly 7, similarly 21 and 30. So in the first iteration, you have got the smallest element at the index 0. Have you got it? And then what will be the second iteration? In case of second iteration, what will happen? I will start from here. In first iteration, I started from the 0th index. In the second iteration, I will start from the first index. So what I will do, I will start from here, I will pick this one, and then I will keep comparing the rest of the elements just like I did earlier, right? So I will compare 8 with 17, right? So keep the 6 as it is, 6 is placed where it should be. Now compare 8 with 17. What happened? This is smaller, so 8 will come here. 17 will be swapped with 8, right? Similarly, now we have 20. So 20 we will compare with 8 because now 8 is at the first position, right? So what will happen? 20, we are not going to swap it because 8 is at this location, right? Which is smaller than 20. So 20 will be here. Similarly, same stories for 9, same stories for 11, same story for 22, but not the same story with 7. When you reach to 7, you find that 7 is smaller than 8, right? So what you will do? You will simply do like this. You will swap and it will look like this. 7 should be here and 8 should be here, right? 8 reaches there. Now you will go to 21, no swapping needed. Now you will go to 13, 13 is greater than 7, so no swapping needed. Right? So in this way, this is the selection sort algorithm. So first of, when first time I got this problem, someone asked me, I did the same approach. I followed the same approach. You can do this. This will work. But again, we need to think about the runtime. We have to think about how much time it will take, right? How many iterations it will take. Suppose someone says that you need to find out the 4th element, then you will run for the four times. Suppose you need to find out the 9th element, then what you will do? You will run the your logic for the 9 times. I mean 9 iterations of loop, right? 2 iterations of loop, 2 levels of iterations makes it n square, 3 iterations, 3 levels of iteration makes it n cube. So here it's like n, then n, then n, up to what time? 10 times, or the number of elements. So this is also a way you can do. You need to just iterate for the 3rd time as well, and at the 3rd time when you will run, then 8 will be there and rest of the elements will be arranged like this. Something was here, I think it was 8, no, it was something was there, I just forgot which one is there. So 6, 7, 8, we just have to worry about these. So 6, 7, 8 will be arranged at the first 3 positions. Now this 3rd position, the array 2, this will give you the correct result. Okay, but again, when we talk about this algorithm, this way if we are running, then you can see that you are going to iterate the loop again and again, right? But in case you have not studied about the other data structures, like you have not studied about the binary search trees, you are not aware about the set data structure. Set data structure, you know about the set data structure? Basically, set is a data structure which is provided by the standard template library in C++. If you don't know that, then let me tell you that STL is a standard template library provided by the C++ compilers. And in this STL, there is a set, templatized data structure. I hope you might have studied about the templates. If no, then you can go and understand. If you have not studied about these things, then the previous solution can work for you, but that is not obviously the most efficient solution, let me tell you. Okay, so let me give you a brief idea about the set here, because I'm going to tell you one more way that how you can find out the 3rd largest element, 3rd smallest element, right? Set, when we talk about the set data structure, there are certain functions like insert function is there. Using the insert function, you can insert a particular element in the set, and whenever you insert an element in the set, those elements are arranged in a in a ascending order, right? By default ascending order. If you give there is an option to provide an option like if you want to arrange it in ascending or in descending order. So by default it arranges everything in the ascending order. So when you give this set and you keep inserting the elements in this, then you just need to iterate it once. You will iterate it once, and in this set, what it will do, it will keep arranging all the elements as you will insert in the set. This will keep arranging all the elements in the set in the increasing order, right? By default increasing order, and we need it in the increasing order, right? So it will keep inserting all the elements in the increasing order in a sorted manner. Okay, so inside this set is a data structure which is using an underlying data structure, right? Set is also doing something to arrange these values. It's not like this is something special. Internally it is using binary search trees and red black trees. Either it uses binary search tree or it uses the red black tree, depends on the compilers who has provided what kind of algorithm. Earlier it should be BST, but with the new compilers it's RBT. It's red black tree. Red black tree is the most efficient tree which arranges the element in a faster manner, right? And retrieval is also fast. You have to when you have to find out the things like which element you have to find out, the retrieval and the searching is very fast, right? So red black tree is the underlying data structure which is used by the set. So when you will insert these elements one by one into the set, these elements are basically getting inserted into a red black tree, and then you will try to find out the element at the third position. You keep iterating the set. If you have not studied about the STL, then just go and go through it. But if you have studied about it, you are a professional, then obviously you should know about these data structures. But if you are a student, then this video is up. This video is done for you. If you have not studied about the STLs and if you have not studied about the other data structures like red black tree or even the binary search trees, right? You can also do one thing, like rather than using set, this set is also fine. You can do that. But rather than using set, if you want to use some binary search tree, if you have an understanding of binary search tree, then what you can do, you can create a binary search tree as well, right? If you will create binary search tree, then you just need to iterate that binary search tree in order traversal. I hope you know about the in order traversal. I will try to explain these topics one by one, like binary search trees, arrays, not arrays, binary search trees, red black trees, everything. But I'm assuming today that you have some understanding on these things, right? So if you have understanding of binary search tree, and if you know that what is in order traversal, what is pre-order traversal, and what is post-order traversal, then it will be very easy for you to understand, right? So if 17, 6, 8, 20, all these elements we put into a binary search tree, then after putting those elements into the binary search tree, and if you do the in order traversal, like 17 and then it will be 6, I'm not going to explain that how I am filling this, right? Because this is not a binary class, a binary search tree lecture. So I'm just going to put it like to show you. I hope you know what I'm doing if you are aware about the binary search tree. 9 will come here, then 11. 11 is smaller than 17, so 6, 8, 11 will come here, then 22. So 22 will come here, then it comes 7, so will come here, then 21, so it would be like 21 here, then 13, so it would be 11, then 13, right? So this is the binary search tree which will be prepared, right? And after you can use the aerial tree as well. And now once you have created it, you just need to do an in order traversal. In order traversal, you visit the left first, the left tree first, left node, and then you visit to the root node, and then you visit the right node, right? So you will start from here, right? So what you will do, you will start from here. So which one will be the leftmost element? 6 is the leftmost element, right? Because here nothing is available, it's null, right? So this is the leftmost child, right? So first element would be 6, then you will go to the root. It was null, so null has not been printed. Left is null, so null don't need to print it. Root was 6, and then the right tree is this. But if you go to the right, then again the same thing will be applicable. Left, root, right. So you will come to here left, then you will come to root 8, right? And now stop here. You don't need to iterate entire binary search tree. You just need to iterate the binary search tree in order traversal till the count of nodes visited becomes 3. If you are ever aware about the binary search tree, you might be aware that binary search tree in order traversal gives you the elements in sorted order. Okay, so you just need to do the counting and you need to find out if count has become 3, then you need to stop the in order traversal that place, right? So once you stop at the third place, 8, then that is your third smallest element. Okay? So these are the different variations you can try, you can discuss whenever you discuss with someone else. Whenever you discuss with such kind of problems, you can have a good discussion with that guy using that problem. And you can also in your applications, day-to-day programming, you can use these things. You can discuss these things. You can find out which one is better and which one is not. Okay. So that's it for today, and I hope you might have found it useful. And more will be coming soon. So more videos will be there. In algorithms, I will try to cover most of the things from the data structures as well. Like I will try to cover the binary search trees, I will try to cover the heap, I will try to cover the B trees and all those things. Okay, so I will meet you soon. Till then, have a nice day and bye-bye.